We are going to do something, there's going to be way less math in this section. It's going to be more of, not vocab, it's kind of like a vocab day today in some respects. It's more of a, what makes a function, what makes a relation a relation. If I take a relation and put it on a boat, does that mean two people are dating? A relationship. A relationship. Too many crickets. All right. So a relation is an input to an output. So we have some set of rules that say if I put in a number, I know I'll come out. This would be like your profit based on how many widgets you make. If you make 10 widgets, you have an output for profit, right? So you see this usually as like y equals something times x, or pretty much everything you've ever seen is a relation of some sort. It's how long will it take to get somewhere given how fast you're going, right? You input how fast you're going, the output is how long it'll take you. You know what I'm saying? So anything you've ever dealt with is some sort of relation. There's different ways to write it. You might have seen this bubble notation before. I know I taught last year in Algebra 1. It's just saying point A goes to 2. So when I look at A, it goes to 2. B goes to 1 or 3. And C goes to 3. Fun fact for you. We'll get to this eventually. But this would not be a function. I'd write this by it. Because that's going to be the big thing they're going to ask you on the homework and the test. And in pre-calc and calc, if you go onward. Because if something is not a function, you don't have to deal with it as much. Okay? It's not a function because a function is something where if I have one input, I know exactly where it's going to go. Do I know where B is going to go? No, so it's not a function. It is a relation, not a function. Okay. You could also use the arrow notation. I've never seen that one used before in any book or anything, so I'm not worried about it. But this one I have seen. Ordered pair is used a lot, where you just list the points that you have. You list the points. A goes to 2, B goes to 1, B goes to 3, C goes to 3. That's the same thing as the map you saw. It's just another way of writing it. This is a very common way to do it. We're going to do that a few times. Again, I'm going to keep writing this. This is not a function because it's not fun. I'm sorry. I have 2 x's going to different y's, so it's not going to be a function. All right. Are we good? Now, this is an important vocab to know. This is blacked out on your guys' notes that I gave you, so write it on top. This is the definition for a function, so start it. It's an important thing to know because we're going to be talking about functions the rest of the year is what we're going to be doing. Well, the next 14 weeks. 14 weeks. It's wild. We put the fun back into function. We'll be doing some number crunching. All right, cool. So again, I alluded to it before. Every input only has one output. Now, I could have multiple things I put in and get the same output. Like x squared is a function. What's 2 squared? 4, right? What's negative 2 squared? 4. Same output, but still a function because everything I plug in only has one answer. There's no multiple answers. I don't know if you guys have ever seen a not function before, but we will today. I'm going to show you guys what equations can look like that are not functions. Look at us flying. All right, let's determine if these are functions or not. When I'm determining if they're functions, the main thing I'm going to look at is my x, okay? Yeah, I'm going to look at x. The biggest thing is if there are multiple x's that go to different numbers, it's a no. If every x is different, it's an automatic yes. Okay. So when I look at this relation, do I have any repeats on my x's? Yeah. Do they go to different numbers? Yeah, so that is a no. Well, I'll put not a function. That's how you can become an x if you start going to different numbers. Never mind. I digress. I digress. All right, this one. When I look at the x's, are there any repeats? Nope. So do they all go to a number? Do they all go to something? Yeah, so that is a function. That's a yeah. Everybody's happy here. But yet the y can get away with it. Like the y can go to two different x's. Like that's not fair. That's a never mind. It's just that's true. All right. This one. Look at the x's. Are all my x's different? Yep. So that is a function. Yes. Yeah. I think there's one on the test like this actually. So multiple x's. The y's do throw you off though. Y's mean nothing. As long as they go to a number, and actually they don't even all. We'll get to that. But that's how the ordered pairs are going to look when we do it. All right. Now we got to talk about domain. A relation can have many values in their domain. Big thing here I want you guys to know. You may have talked about this at some point in your career, and if you haven't, that's fine too. X is your domain, and Y is your range. So when we are going to be talking about these functions or actual equations, we are going to be saying, what can X be? What can Y be? And that's going to be important for, like, I always say this, algebra can be kind of tough because we're going to do all this stuff and you'll never see real life application. But if you are working in a factory, if you're working, like if you're an engineer of any sort, domain and range is important because that tells you what the possible values you can actually use are. You know what I'm saying? Like in here, it's just going to be an arbitrary thing we have to find. But if you go onwards in math, domain and range is extremely important because you might say, hey, this could be our profit, but it's not within the domain or it's not within the range, so you can't actually use that value. Okay? So domain and range is going to be more important if you move up in math. Here it is important just to understand what functions are doing. Okay? We'll get to that. We'll do a few examples with those in a little bit. Now for the wild ones. They're the ones that involve math. Oh, hey, I wrote down stuff to tell you guys in my notes. Let's see if I did it so far. Yes, I did. All right. How do you think I can figure out if this relation contains that point? What should I do with those two numbers? Same thing you do with your phone when the battery's dead. Plug it in. This is my X and this is my Y. I plug it in and see if it's true. So I do 4 minus 6 times -1, and I see if that equals 10. So that becomes 4 plus 6. That is a member of that relation. I plug them in and see if it works. Whew. All right, what do I do? I plug it in and see if it works. Uh-oh. Does 11 equal 10? No. This is not a member of it. Okay? You guys good in this, or do you want to see more of it? Good? If you really want to know and check yourself, I'm pretty sure this one was and that one wasn't. No, it's just saying if there's a question, is this point part of this? You plug it in and see if it's true. Yeah, sometimes. Let's look at this beast. Give you a hint on what we're going to be. Does this look like something you dealt with any time in your life? A y squared on one side. Maybe circles, equations of circles that comes up. So we're dealing with y squareds now with x's. So this is where things are going to get a little bit dicey. You might not have. You might not have ever done this before. So what I'm going to do is I want to look at these ones. I'm just going to look at these 2 points for a very specific reason, okay? I'm going to plug them in and see if they work. So I'm going to plug in 12 for x and negative 6 for y, right? Make sure when you're plugging in these numbers, put them in parentheses, right? Even when I taught calc, this is still probably one of the number one mistakes made is people say that's negative 36 because you plug it in your calculator and that's what it tells you. Put it in parentheses. 36 equals 36. So this is a point on that relation. Plug it in. 6 squared. So 36 equals 36. This is on it as well. Now, that's intriguing. What's true about these two x values? They're the same. Do they go to different y's? So is this going to be a function? No. So keep this in the back of your mind. This is not a function. Can I still use this for calculating stuff? Because it's still a relation, but it's not a function. And if you're not a function, some wonky stuff happens in further math. Then it would not be a part of it. So like this one, right? So if I did negative 3 squared equals 3 times negative 3, right? So 9 equals negative 9. So that's not a point on that. So if these weren't equal, it could still be a function. We don't have any proof yet that's not. That's a good question. Yeah, so that is not on here. These are both on it. We'll get to it when we graph it. We'll use decimals to graph it. All right, we're going to graph it. So I'm actually going to cheat, if that's okay with you guys. That's also...
Under x?
No. All right, so here we go. Let's take a look at what these graphs look like on Desmos and see if we can't... Again, I'm going to cheat. How would you... Well, before I cheat, or as Miranda Lambert once said, before he cheats, if I went to graph this, I have 2 ways I could do it, right? I could make my t table, right, and make an xy chart and start plugging in points. Like if I plug in 0 for x, you just set up your equation and solve for y, right? When I plug in 0, y would have to be negative 10/6, right? Or you could do negative 5/3 if you're cool. So could I go through and make a t table for that? Yeah. Will that work for that one as much? No, because you guys don't know what the shape is going to be. So a t table, you'd have to get a lot of points because you guys have no idea what that's going to look like. What I would do if I ever had to graph that by hand is I would get y by itself, right? Doing that. That becomes a positive, right? I'll just leave that as 10/6 because why not? So once I get y by itself, that's something we can graph, right? I have an intercept and a slope. So that's how I would graph it if it was linear. This one, I'm going to go right to tech. Okay? If you're using a TI-84, there is a really nice video posted on how to graph those things, and I'll kind of talk about that actually how you solve it. But I'm going to cheat and use Desmos, and we can take a look at what's happening. So the first function we had was x minus 6y equals 10, right? All right. Oh, that's our y-intercept like we found, right? So we're good. We're good. All right, that's a beautiful graph. Anything scary there? Does that make sense that that thing is a linear function? There's nothing squared in it. Just good old-fashioned line. We're going to get to why this graph's important. Now let's graph the other one. The other one was what? Y squared. Help me out. What was it? Y squared equals. All right, let's see what this looks like. Mamma mia. Look at what that one looks like. What? It looks like a sideways parabola, right? So does it make sense? Well, when we did before, we have 2 points that are on it, right? We had, what was it, negative 12, or 12, 6, and 12, negative 6, right? And 12, 6, 12, negative 6. So we had those 2 points, and it makes sense. And we know it's not a function because my x has 2 options to go to. When I plug it in, I don't know which one it's going to go to, just like my real x. So if I connect these dots, this is a prelude to something. That's a vertical line, right? You may have learned about this. This would fail the vertical line test. Okay. Here's something interesting too I want you to think about, which we're going to see in a second. But put this graph, maybe jot this graph down on your paper so you have it underneath your, like where it said graph it. Just jot that graph, because I want you guys to see why that graph is the way it is. I'm going to show you how I can make it into 2 functions, which you won't have to do, but might help you see why that beast is the way it is. All right, what a beautiful graph. But hold on to that. So back in the day when you guys were little running around, everything was y equals, y equals, y equals, right? You get to a point, everything becomes f of x. That's called function notation. F of x equals something, and it's f of x is equal to whatever it is. So when you ever see that x inside the f, it's f of x. Now, do I have to use those letters? Absolutely not. If I'm doing like number of widgets I make equals my profit, you could actually do n of x equals something. You can do any letter you want, actually. And sometimes they will do that. The function in relation to x.
A fancy way of saying y?
No, no, it's not, actually. No, it's good. That's a generalization, because y is also arbitrary. Yep, you've been living a lie, man. Never mind. I'll take it back. All right, so f of x equals 7x minus 2. The function is described by, or the function of x is equal to that expression. So if I do f of 2, everywhere I see an x, what do? Plug in a 2. Everywhere I see an x, what do I plug in? Negative 4. Never stop using parentheses to plug stuff in, okay? No matter what level, no matter what you're doing for math. That's going to be the biggest advice I can give you.
So how come we don't plug in the 2 or in the x of f of x?
Oh, you did, though. Yeah, because they're telling you, yeah, that's what they're asking. They're saying when we plug in 2 for that x. Okay, are we okay on this? I need to wear this like on a chain and just have it like at the, yes. All right. Doesn't matter. Uh-oh, this one's on F. Does that make any real difference? No. It's h of x. And a lot of times h is a common one. They'll do g of x, f of x, h of x, because if you have different functions, you know which one to plug it into. So for this one, h of -4, everywhere I see an x, I'm plugging in -4. What's that? 16 minus 8 minus 9. Okay. How do you guys feel about that? Are you guys okay with that? If you want more examples, again, the other videos that are posted have the other ones done, okay? So don't feel bad watching those. Just make sure parentheses, parentheses, parentheses. What if I change this question now? What is x if f of x is 12? So what am I looking for on this one? X. What do I have? I know what f of x is. So I can take this and plug it in for f of x, right? Wherever I see f of x, I'm going to put a 12. Whenever something's equal to something else, I can plug them in for each other, right? And then it's good old-fashioned solving. So x would be 2. Yardnar. I'm not plugging that in for x because there's nothing in there for x. I don't know what x is. I'll set up one more time. I'm going to take that and plug it in wherever I see an f of x. Sorry, I'm going to use this space right here and run out of room. -31 equals 7x minus 2. Solve it. Uh-oh. Can I write my answer as a fraction? Yeah. Hey, pay attention on the Moodle. Sometimes they want fractions, sometimes they want decimals. All right. Do you guys have questions on that? Are we okay? We're going to skip, if you guys don't mind, then we're going to skip that one again. Go ahead. Video's posted. If you want more examples, by all means, this is a good one. Or you guys can, if you want extra practice, you can always try these ones and then check yourself by watching the other video that's posted. All right. So how can you tell if an equation is a function if all you're given is the equation? Good question. Ooh. Hey, can I write something in function notation if it's not a function? So in order to be able to write something in f of x, what do I have to be able to do with my expression is get y by itself. If I cannot get y by itself, it's not going to be a function. So if I'm given a relation and I need to determine whether or not it's a function, I need to get y by itself. If I can't, it's not. So for example, this one, can I get y by itself on this? Can I solve this? Yeah, we did it earlier, right? I can do my -x plus 10 equals -6y, and then divided by 6, -6. So you can go look back. But can I get y by itself? Yes. When I graphed it, did it look like a function? Yeah. If it looks like a duck and talks like a duck, it's probably a function. That's true. All right. I'm not going to worry about independent, dependent. Now, what about this beast? Can I get y by itself? Sidebar. Let's have a little chat. If I have x squared equals 64 and I want to solve that, I square root both sides, right? When I square root it, is the answer just 8? No, whenever you square root to solve, it's always plus or minus 8. So there's 2 answers, okay? So put that in the back of your head. So on this one, how do I get y by itself? I square root it. As soon as I square root it, how many answers do I have when I square root to solve? 2. So I have plus and minus root 3x. So technically, you have 2 answers. So can I get this written as y equals one thing? No, so that's not a function. And that's also why the graph of y equals square root of x looks like this, right? The graph of y equals negative square root of x looks like that. Is that what we had?
Wait, say that again.
Which part? This one?
No. The y is.
Oh, so when I solve this, whenever you square root to solve, you get the plus or minus. So because there's 2 options, it's not a function. Because there has to be 1 output for every x. This one, there's going to be 2 different. You don't know which one's going to do each time. Yep, but there's still 2 different things. Back before when I solved it, I only got 1 equation. This one I got 2. If you get 2 equations, it's not a function. So here's a shortcut for you. If you end up with a y to an even power in your expression, it will not be a function. Like y squared, y to the 4th, y to the 6th. It's automatically not going to be a function. Because when you cube root something, that one does not have the 2 values. Cubing is okay. Determine whether these are a function. You guys want my shortcut way? Don't. If you want to watch the long way, watch. But I'm going to tell you the way this will work every time. Is y to an even power? So that's going to be a no. Y is to an even power. It's an automatic no. Because when I go to solve it, my last step will be square root. And when I square root, I get the plus and negative. Can I, again, when you cube root something, when I cube root it, I do not do plus or minus. If it's an odd power, it's a yes. Okay? Even power is not a function. Odd powers are a function for y. X can do whatever it wants. This is the tricky one. X equals 4. That looks like that, right? I can't solve for y, which is actually a dead giveaway. Can I get y by itself? So that's probably going to be a no. So that's one way you could look at. Can't get y by itself, not function. Is y equals 4 a function? Is a horizontal line function? Yes, because you can get y by itself. This one, there is no y. The other way I could look at it is I have the point, 4, 0. I have the point 4, 1. I have the point 4, whatever. I have a bunch of x's going to different points. And that's not good. That's not a function. So the biggest thing is, can you get y by itself? If the answer is no, it's no. I would probably graph these as well and check them, because that's the easiest way. All right. Vertical line test. I'm skipping that one. This is the one that everybody loves because there's no math required. Vertical line test says, if I draw a vertical line anywhere on the test, it cannot hit more than 1 point, and it's still a function. Can it hit no points? Yes. Can it hit 1? Yes. Can it hit 2? No. That's it. If it hits just or no more than 1 point, it is a function. This might be a new one for you. It's called one-to-one. We're going to deal with that later. 1-to-1 is the horizontal line test. Okay? A function is 1-to-1 if it passes the horizontal line test, and that means you can find an inverse of it. And we're going to deal with inverses later. And just a reminder, we're going to do 3 chapters the first 3 weeks. Next time we do 2. One of the units we do 1, and one of the other unit we do 2. So this is by far the fastest we're going to go the first 3 weeks because we're covering a lot of stuff at once. All right. So let's graph these, and then we're going to see if they're a function. If they're a function and if they're 1-to-1. So I'm going to grab my Desmos once more. I'm going to graph these beasts. Well, I already graphed the red one, right? The x is minus 6, y equals 10. Can I make a vertical line here? Let's see if I know how to do stuff. All right. So this is my vertical line. Can I drag it? Yeah, I can drag it. If I take this vertical green line and I go through my red graph, is there any point I'm hitting it twice? Nope. So that is a function, right? That's a yes function. So x minus 6y plus 10 is yes, a function. Now 1-to-1, what do I use? I'm not using a vertical line. I'm going to use a horizontal line. Let's do y equals 0. Oh, purple. So when I take this purple line and I start going up and down that horizontal line, is there anywhere I hit it more than once? Nope. So I also passed the horizontal line test. So it is also 1-to-1. Okay? Again, vertical, horizontal line test. All right, y squared equals 3x. Let's look at that one. Well, we already know it's not a function because we proved it, but when I drag that line, do I hit it more than once with a vertical line? Yeah, so non-function.
You know that right away.
Yeah. So what I basically did is I showed you guys, you could try to get y by itself, you could graph it, or you could look at your xy chart, are all ways to determine function. They'll tell you the same thing. But honestly, the quickest way, oh, I hit it twice with that green line, automatically not a function. But now with my horizontal line, do I ever hit it more than once? No. So it is 1-to-1. Vertical test for function, horizontal line test for 1-to-1. Okay. Let's see if we'll do one more like this, and then I'll show you guys, because usually we'll just give you a graph. Yeah. Ooh, what do you guys think this one's going to be right away? All right, let's test it. Let's test our hypothesis. All right, so we're going to do x, holy function onlys. Sorry for my language. This was plus, was it 4y? I was really good at my job. It's amazing I use a computer with how old I am. Oh, let's look at this beast. That's a pretty graph. All right, when I look at that, it's a thing. No, that sigma's when you add up all the values. All right, so I have x to the third. Is that a surprise? Could I have guessed that wasn't a function just by looking at it because the y squared? Yeah. But when I draw a horizontal line, do I hit it more than once? So I'm justified. It is not a function. Now, if I draw a line like this, do I ever hit it more than once? Horizontal line. No, so it is 1-to-1. Here's my advice. Being a function, you look at the y. Being one-to-one, you look at the x. Because y equals x squared looks like this, right? Is that going to be one-to-one? If you draw a horizontal line, no. So one-to-one is the same thing as looking at a function. You're just looking at it different way. I'm pretty confident most of the time we're going to ask you that based on the graph, though. All right, so like, here, look at these beasts. Ooh. Is this one a function? Can I draw? Do I hit it more than once? Yeah, so it's no. Not a function. Does it pass the horizontal line test? No. Not one-to-one. Neither. It's just a, you'll never believe it, but that's actually a function of x squared minus y squared is what that looks like. So it has both are squared in it. Is this one a function? Yes. Remember, f of x means function notation. Is it one-to-one? No. Horizontal line test. If it had to be one-to-one, it can only hit at most 1 point. It can't hit more than 1 point. So like technically, that doesn't matter. You can hit 0 points. There's some graphs that you just won't. There's no values there. But once you hit more than 1 point with a horizontal line, it cannot be one-to-one. Ooh, that one has a break on it. All right. Any questions on that? Or are you guys okay? That was a lot. Pew, pew. Guys, if you see a break in it, don't worry about it. Like if you see one like the last one, this one looks scarier, but it's still, ooh, this is the last one of this one. If you look close at your paper, this is an open dot and this is a closed. So does it actually hit 2 points at that spot? No, because the open point, it whiffs, right? It doesn't actually touch it. If those were both closed dots, it'd be a fail. If those were both closed dots, because it hit twice. That spot right there.
So what's an open dot, closed dot?
Open dot means it does not equal it. A closed dot means it does. So that open dot means it goes close to it but doesn't touch it. So this would be a yeah. It's actually yeah on both. Okay. So I just want to talk about that one. All right. Good. That was the long part. Yeah, there's more. We're only halfway there, bro. I'm having fun. This one's gonna be quicker, but like I said, I will go long today. If you need to go where you need to go, that's fine. I need to finish this.
Like 2 minutes long or like
10 probably. No, not the full one time. Whoa, that's not Jiminy Crickets. I feel so old all the time. It's on my other screen. I don't. All right. X is domain, Y is range. That's all we're going to talk about right now is domain and range. Inputs are your X, and that's your domain. Outputs are your range. Home on the range. Yeah, we'll go get through this. There's almost no math. Yeah, there's math. All right, so determine the domain and range of these two beasts. So my domain, these are from the last one, right? My domain are all my X values. What are my X values? 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. That's my domain of that function. That's everything X can be. My range is my y's. 2, 3, 4, 2, 3. Now, if 2 comes up twice, am I going to list it twice? No, I don't need to list it twice. So 2 comes up, a 3 comes up, and a 4. That's all my y values. If that is the only thing on the test, you guys be content. Again, my domain's all my x's. Range is going to be all my y's. Are you going to do domain and range if it's not a function? No. Relations don't have domains and ranges. All right. That's the hard part. The big thing I want you guys to realize is a majority of functions we see is all real numbers. Like when you graph most functions, it goes from negative infinity to infinity, right? That means x can be anything in that. It's all real numbers. Okay? So majority of the time, it's going to be all real numbers. There are 2 cases that it's not, and those are the 2 you really need to focus on right now. There's 2 things that happen. Number 1, I cannot divide by 0. That will break up my domain. Right? So if x is on the bottom can't be 0. When you graph that, it doesn't exist at that spot. And also, we are dealing with real numbers. I cannot square root a negative number. Okay? So,
Morning, high school pirates. Just want to remind everybody that today, so Thursdays,
board game club. All right. So 1 over x. What can't x be? If I'm given the function 1 over x, what can't I put down here? What's the only thing? Can I plug in -1? Negative a million? E? Can I plug in 0? So x can't equal 0. That's my domain. It's everything, all reals, but x can't be 0. It can be anything else it wants to be. For this one, can I take square root of 0? You can. 0 times 0 equals 0. Can I take square root of -1 in real numbers? No. So this, x has to be greater than or equal to 0. That's my domain. That's the only 2 cases we have to worry about. Everything else is going to be all real numbers for this section. Okay, we're going to introduce new functions as we go. That's like what some of the other chapters about. For right now, those are the 2 to worry about. We're almost there. Told you today would be a rough one. All right, find the domain of these beasts. It looks scary. This function, if you graph it, just looks like this, right? Is there anything I can't plug in for x? Can I plug in 0? Is it going to go that way forever? Is it going to go that way forever? So the domain of this, you put an R, or that's the same thing as all real. Okay? All real numbers. There's nothing I can't plug in because there's only 2 cases they have to worry about where it's not going to be all real numbers. Okay? And, oh, they're right here. If I have a bottom, what can it not be? 0. So whenever you have a bottom, you say that can't be 0. I just say, like an equality. So what can't x be? 5. That's your domain. All real numbers except 5. So you'd actually write it that way. It's all real numbers, but x is not 5. This is calc stuff, actually. This is the first unit of Calc 1. This is what we do. Square root. I cannot square root a negative. So I'm going to take this beast, and set it greater than or equal to 0. So x has to be greater than or equal to 11. That's my domain. Those are the three cases you're going to see this chapter, this unit. If you want to do interval notation because you're cool now, that's what you do. I'm not going to make you do interval notation for these two. No. All right. Domain of these. Is that a square root function? It's a cube root. Do I worry about odd powers and odd roots? Never. That's odd. You guys are odd. All real numbers are. Ooh. I have a bottom. It cannot be 0, right? I'm factoring on this one. This bottom factors into what? X plus 5, x minus 3. I don't give any with an a in front for right now. So what are the values I plug in that this would equal 0? What plus 5 equals 0? Negative 5. What minus 3 equals 0? 3. That one I did pretty quick. Yeah, we'll get you there. Uh-oh, this is not a square, but it's even. All the even powers act the same. So what do I do with this one? Set it greater than or equal to 0. X is greater than or equal to negative 10. Questions on that? 3 cases. It's all real numbers. Set the bottom equal to 0, greater than or equal to 0. For that? Yeah. Oh no, if it's a square root or an even power root, it's always greater than or equal to 0 because you can't have a negative in there. 3 cases. Regular, a fraction, a square root. Square roots are always greater than or equal to 0. Everyone's having so much fun. Last thing we're going to do. What to do when we look at a graph. Can I find a domain and range when I look at a picture? I got good news for you. No math required. Let's look at the picture. I don't know if you guys can see this. That's an open dot and that's a closed dot. Okay? That makes a big difference. I'm going to write this domain and range in interval notation to make my life really easy. So domain is x, right? Domain is x. So just look at your graph. What are my x's? This x is negative 2. This x is 3, right? Now, is negative 2 part of it? Is it a closed dot or open dot? It's closed, so negative 2 gets a bracket. 3 is an open dot. It gets a parentheses. So actually the graph ones are the more straightforward ones. Now what about my range? My y. So y is up and down, right? So think about your range. This is my range, right? How far do I go down? How far do I go up? My lowest value is 1. Do I hit 1 actually? Yeah, there's no open dot, so I hit it. And then I go all the way up to 10. If you have an open dot, no. I think that was an open dot. Open dots get parentheses. But for the range, the open dot's not part of the endpoints. So if this was an open dot right here, that would have been parentheses at 10. Open dots get parentheses. Everything else gets the other one. One more, and then I'm calm your body. This guy acts like he's never worked before. Hey, opportunities missed by most people because it's dressed in overalls and looks like work. All right. Domain and range of this beast. Uh-oh. Open dot, closed dot. So domain, domain, I'm looking at my x's, right? That's an open dot. So I'm going from -2 to 3 again. That's wild. So domain, I'm going from -2 to 3. Again, close dot, bracket, open dot, parentheses. Now what did I do with this one? How did I do this even? Why am I here? How did I get tricked into doing this? What's my range? So I'm starting at -4, but now I have an open and a closed dot. Which one wins? Closed, because you do have a value at that point. So for my range, I have -4, and I go up to 2.25. It's 2 1/4. Oops. Bracket, because it's not an open dot. You do actually hit that value. You always go smaller number to larger number. Yep. No, order does matter. You do have to go smallest to biggest, right? I did -4 to to +2.25. All right, thank you guys.